Cool, welcome back. Welcome back. Second video of the day. I need to go back a little bit here. Last time it was on creating up to icons into panels, and then you can click to flip the panels. Now it's time to add the buttons, so you can add and subtract these cards. So let's go. Subscribe, comment, drop a like. Let me know how I can make this more fun. I think next section would be more fun. Because I would start coding.
It has two arguments, basically the action, which is a function, and the label, which is also a function. It makes sense that the action would be a function similar to Untitled Chapter had a function right here. But what about label? Why is the label of a button a function? Well, the label is what appears when the user sees on screen to tap on. And usually this would be, for example, a text, like our text that might say add card, something like that. And you can see it's actually appearing down here in the UI. It's a function because it's a view builder. So it's a bag of Lego. You might be making more complicated types of content for your cards. For example, it might just be single text like this. What if I wanted to be add with card on the second line? Well, it's perfectly allowable for me to make a V stack in here with text saying add and another text saying card. Here's my label. Here is the function, the view builder function that's returning the view. So this can be an arbitrarily complex view. Anything you want in here is perfectly fine. So there's add card. And maybe we have another button called remove card. We've got add card and remove card. And the action for each is obviously different. An action for an add card is emoji count plus equals 1. This is emoji count up here. And this button is emoji count minus equals 1. So we got our buttons here. It kind of looks okay. But we have a problem. Same problem we had below with is face up. The left side of mutating operator isn't mutable. Self is immutable. We know that these are immutable. So again, we'll just for demo purposes put this off somewhere else and have emoji count. There should be a pointer to it. And that makes this work. And you might find in your homework that you might want this to end up being @ state as well. A little hint there.
Yeah, this is one thing I want to tell you guys. If you're ever in college, the instructor often sneak in like hints of the homework and on the exams, like questions on how to do well in them. For example, if you have a hint here, your homework would be much easier than someone that didn't attend lectures. Same goes for like the lecture after the exam. The professor will start giving hints on the next exam because no one will show up.
This is nice, but I really don't want add card and remove card stacked on top of each other. I want them, one on each side like this, minus and plus, the minus one on the left and the plus one on the right. So how do we do that? Again, just throw them in an H stack. That will stack these things horizontally, this here. And if I want the second one here, the remove card to be first, I can just pick it up and put it here.
This is getting really messy.
Add card. Try again here. Remove card and add card. Again, not quite what I want. I want them more spaced out. There is another Lego brick that you're going to use that you'll use all the time when laying out called spacer. And a spacer is always going to grab as much space as it can. The remove card and the add card, they're going to be as small as they can just to fit their text. And the spacer will grab all the rest. But this has pushed these a little too far out to the edges. So can you think of how I might make these not go quite so far to the edges? How about if I take this H stack and add some padding horizontally? Move them in a little bit. Code is starting to get messy again. This is pretty long. I told you these views are supposed to be really, really short little views. And so we could turn this button here into a new struct with a little bit of overkill. When we created this card view struct, it made a lot of sense because first of all, it was more complicated. It had the Z stack with all this stuff in, whereas these buttons just have a single button. But second of all, it had all these bars and all these things to configure it, etc. And the buttons really don't have any of that. When you have something like this that's making the code really long and hard to understand, but you don't want to go so far as to make it its own dining room chair Lego, another solution you can do is to create a var for it. We could create a var, let's call it remove. It's some view. It's going to be this button. That's it. And yes, this is saying return, but since this is the only thing inside this function right here that sets the value of this, we don't have to say return right there. And same thing, we could create a var add for the add button. It's some view as well, and just put this button down in there. Now up here, we can say remove, and then a spacer, and then add. And now this code is back to looking really clean and very understandable. The last thing I want to do is change this add and remove to this nice icons here, these plus and minus icons. Where do those come from? If I was writing my own app here, then maybe I would want some images for this and I'd hire my graphic designer to go and do them. But for standard things like give me more of these or give me less of these, things like that, it's really better if you use the same images that all other designers are using out there in the world. Because users get used to it. Oh yeah, plus in a circle, I know that, boom. They click on it with confidence because they've seen it in other apps. Apple has made hundreds and hundreds of these pre-built little symbols. And the challenge for you is just to pick the right one.
Saves a lot of resources.
For you to search around all these symbols by keyword and find the thing you want. Let's look at that first, and then we'll see how we actually create an imaged Lego brick that would show this. The app we want is called SF Symbols, and you get it by going and in your web browser and going to developer.com/sf-symbols. And when you go there, you're going to see this app. There it is, Symbols 2. You're just going to download it and then run it. And when you run it, it looks like this. It's essentially just a big search engine for all these images. And you can see lots and lots of them. They're grouped by type, but you can also search. So like I might say, I want to add something. Now you're getting all the ones that make sense for adding. And you can see here's a plus with a circle. There's also a plus with a square. And it might be thinking which ones I want to do here, but I think plus with a circle is more appropriate to what I'm doing there. Plus.circle is the name of it. Plus.circle. That's all you need to know is this name. When you have this name, you can put it in your code. So let's go back to our code and add that. Instead of this add card VStack right here, two things piled on top of each other, we want a different kind of Lego brick, which is called an image. And when we create the image, there's actually a lot of ways to create images. Remember back here in our navigator, we look at assets. If we drag JPEGs in here and give them names, we can use our image by name there. But if we want one of those SF symbols from that app that we just saw, we want to use system name as the argument or the label for the argument. And then you just do your plus.circle that you found when you looked it up. That is just using a different view for that. Resume here. We see we've got a plus right there. And we can do the same thing for the minus. Go back to SF symbols. Let's look for remove and see what we find. Here we go. We're looking for a similar kind of thing. Oh, there it is. Minus.circle. It's called. So come back. Minus.circle. Image system name minus.circle. A couple of things not quite right here. It's getting close. First of all, these things seem very, very small. We're already using large title here for the text on our buttons.
Wait,
We can do the exact
where did it put the stuff? It's in the assets.
I might be thinking which ones I want to do here, but I think plus with a circle is more appropriate to what I'm doing there. Plus.circle is the name of it. Plus.circle. That's all you need to know is this name. When you have this name, you can put it in your code. So let's go back to our code and add that. Instead of this add card VStack right here, two things piled on top of each other, we want a different kind of Lego brick, which is called an image. And when we create the image, there's actually a lot of ways to create images. Remember back here in our navigator, we look at assets. If we drag JPEGs in here and give them names, we can use our image by name there. But if we want one of those SF symbols from that app that we just saw, we want to use system name as the argument or the label for the argument. And then you just do your plus.circle that you found when you looked it up. That is just using
so those are default, and then you use system name. Whereas some more custom ones are in assets.
Resume here. We see we've got a plus right there. And we can do the same thing for the minus. Let's go back to SF symbols. Let's look for remove and see what we find. Here we go. We're looking for a similar kind of thing. Oh, there it is. Minus.circle. It's called. So come back. Minus.circle. Image system name minus.circle. A couple of things not quite right here. It's getting close. First of all, these things seem very, very small. We're already using large title here for the text on our buttons. We can do the exact same thing and use large title for this H stack of these two buttons. So just like the same thing, I'm padding it here. I'm also going to say use the font large title, and that's going to filter down inside this H stack into all of these buttons, and they've all of a sudden become larger. I could also put a spacer perhaps between this H stack at the top and these buttons down here below. I can even enforce some min length of that spacing. Maybe I want at least 20 points or something like that. But a lot of times you want standard default spacing because, again, it can be device dependent, different on an Apple Watch than it is on iOS. I know it's hard to believe, but these things that we're building, we can build them so they would work on Apple Watch, or even if we're just building a very Apple Watch specific UI, we're using the same tools here. I think we've got this UI how we want it. Let's see if it's working. So I'm going to hit plus. Yeah, 5 cards. 6. Oh, yeah, lots and lots of cards. Minus. Oh, yeah. One thing we weren't very smart about here was that what happens if we go minus, 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 minus? Oh, preview crashed. Why? Because I kept going minus so much that minus count went below 0. And then I tried to create this little range of stuff inside my array where this was negative. So that's clearly no good. So we really need to protect ourselves against those array index out of bounds. So here we'll say if emoji count is greater than 1, then we'll do emoji count minus 1. And here we'll say if emoji count is less than the emojis.count. Emojis.count, this is just a var in array that says how many things are in that array. Now, when we're over here and we do minus, 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 it won't let us go more minus than that. And plus, 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 plus won't let us get to more than 24 of them over here. The last thing I want to do is make it so this code is a little cleaner. You can see that this button has 2 arguments. Both of them are functions. So you can do the thing where you get rid of these keywords and do this outside, even if you have 2 at the end. And you just do it by putting the label of the second one right after the first one. Here I've got this one, then just this label, and then this one. We keep the label for the second one if we're using the last 2, but we still don't have any commas or space or parentheses or any of that. Get rid of the comma in there and all that. So we've got a little bit more to do to turn this into a grid. But before we do that, I'm going to take 5 minutes and just review everything we've learned so far. We learned to build user interfaces with SwiftUI by building these data structures that behaved like a view. And this idea of building a structure that behaves like something is the fundamental underpinning of the functional programming methodology in Swift. Now we learned that Swift also does object-oriented programming methodology, and that we're going to combine those 2 methodologies next week when we add logic to our application, but that the UI portion is all functional programming. We learned that a view is a rectangular area on screen. It can draw, it can receive multi-touch events. And we learned that just saying that we behave like a view gives us enormous power. For example, we can set fonts in our cells or set our padding, or even handle a tap gesture just by calling a function on a view. But even more importantly, we learned that we could put views together to build complicated user interfaces. And we get all that mechanism just by saying we behave like a view. But with that great power comes a little bit of responsibility, which is that we have to implement this one variable in our data structure called body. And this body's type is some other view. So the body of our view is some other view. And this might have been initially perplexing, but it made sense once we started talking about views like Legos, where we're going to piece them together to build more powerful Lego, like
Good
dining room chair
summary.
Lego, and then piece that together with other more powerful Legos to make a dining room Lego, and then a house Lego, and then neighborhood Lego, universe Lego. And once we had this model, it all made sense that the body of a given view is some other view. Now, the value of this variable is calculated by executing this function, which just gets dropped right in the middle of our code. And we found that dropping functions in the middle of the code is something we do all over the place in Swift. We did it a dozen times in building this user interface until it became commonplace for us to do it. Now, this function obviously has to return something that is a view, and we know that the compiler is going to replace some view right here with whatever the actual view that's returned from here is. This view that we're building in here, we make it somewhat out of individual Lego bricks, like spacers, and also images, and also text down here. But largely, we make them out of these view combiners, or Lego combiners, we call them. These Lego combiners, they are created like Lego bricks. They might even have arguments, alignment or spacing or whatever, but they all are going to also have this argument, which is another function that's dropped in there, which is a list of the views for it to combine. And that list of views we call a bag of Lego view, and it's made with kind of a special functional syntax called view builder. So these are view builders. They allow us to just list our views, right? 1, 2, 3 views right here, or down here we've got these 3 views listed. We noted that we can also do if-thens to determine which views get into our bag of Lego, and we can even do local variables to clean up our code as well. Along the way, we learned another way of doing bag of Lego, which is for eaches. For each creates a view for each of the things in an array. This array, or in our case, a little subpart of an array, has to contain things that are identifiable so that the for each can keep track of which things in the array match with which of the views it is creating. It normally does this by requiring the things in the array to behave like an identifiable. Just like we say our structure behaves like a view, we could say that the things in this array behave like an identifiable. And all it means to behave like an identifiable is that you can identify it, uniquely identify that thing in the array from all other things in the array. Well, we're putting strings in here. Unfortunately, strings do not behave like an identifiable because 2 strings that look exactly the same might be different strings. So we kind of cheesed it with this little argument right here that forces the for each to think that each of the strings was itself identifiable. And then we made sure to never put the same string in our array twice. So that's a bit of a cheese. When we do our actual app, we'll be putting cards in these arrays. We'll be for eaching through cards, not emoji. And the cards will, of course, have to have some sort of unique identifiability. And that's something we will cover when we do our cards next week as part of our logic. Now, we learned, of course, that these view combiners, when we gave them a bag of Lego, that the Lego that was inside their bag of Lego could be more view combiners that have their own bag of Lego. And those bag of Legos could have more bag of Legos inside of them. This allowed us to build pretty complicated user interfaces. But our code started to get a little bit long, and we know that the design methodology of SwiftUI is that we want our views to be really small, not a ton of code. So we started factoring out some of the code. One way we did that is by creating a dining room chair Lego, creating our own struct that behaved like a view that represented a little piece of UI, in this case, one of these cards. And when we did that, we learned that these little dining room chair Legos could have variables that would configure how they look, whether it's face up or face down, what sort of emoji is on the card. And finally, we learned that we could also factor out some code just by creating our own little vars, that this body var up here was not the only view that we could create. We could create our own some views, for example, to add a button and put that inside with just referring to the var. And this cleaned up our code quite a bit. And that's all there is. Next week, we're going to be adding logic, and in the weeks after, we'll be adding things like animation. But all of those things are all going to be within the framework of building UIs in this way. There's really not a lot more to it. There's a few more view combiners for us to learn. There's a few more of these Lego bricks for us to learn. And of course, there's a lot of view modifiers for us to learn. But for the most part, you've already learned the fundamentals of building SwiftUI apps.
Yay.
Okay, the last thing we want to do this week is put our cards into a grid instead of all horizontally like this. And we want them like this. We also want them to look more like cards, not these tall.
Don't you just
Before we go off and do that,
restack
though, I
them
want to
again?
address one other issue here, which is these buttons down here. See, these ones are blue, and the ones over here are red. So why are these blue and these red? Well, this blue is kind of standard control blue in the UI. And we really want these buttons right here to be blue because when users see this blue, they think, oh, I can probably touch on that. This red, it's pretty obvious, but they might not be 100% confident that they can click on it. And then we'll go do the grid. So let's jump back and do that. The red is actually very easy to understand why these buttons are red. It's because this foreground color red is being applied to the entire VStack of our UI, including the buttons. Fixing this so that only the cards are red is a simple matter of taking this foreground color out of here and putting it on this H stack that has our cards, so that it's only affecting this H stack. Sure enough, now the cards are red, and this has reverted to its proper default standard control blue. Now that we fix that, how do we make this H stack here into a grid? This is very straightforward. We're just going to replace this H stack with a new view combiner called a lazy V-grid. We'll talk about why it has the word lazy in its name in a few minutes. A lazy V-grid basically lets you specify a number of columns, and it's going to make that many columns here, and then it'll make as many rows as necessary. And yes, there's a lazy H-grid where you specify the rows here, the number of rows, and it'll make as many columns as necessary. So this is really great. Unfortunately, you can't specify the number of columns just by putting the number here, like 3 columns. Instead, you put an array of grid items. So however many grid items you put here, there's 1 grid item, here's 2 grid items, here's 3 grid items. The more grid items I put here, that's how many columns it makes. why does it do grid items here as opposed to just the number 3 that I want 3 columns? Well, because these grid items let you control the columns more. This lazy V grid, of course, more powerful than just give me 3 columns and I'll do it for you. For example, I could put in here grid item fixed at 200 wide. And so now this first column is fixed at 200 wide. The other ones are just fitting in whatever space is left over. And that's because the default in here is actually something called flexible. These are flexible grid items, and so they'll flex to whatever space is available. But we're going to go back to just normal 3 columns that are the same. And we're going to try and understand what's going on with our UI here, because the cards have changed shape. They're kind of these short little guys. They're wide, but they're short. They don't really look like cards much anymore, although they didn't look much like cards when they were in HStack either. They were really tall, way too tall for being cards. And why is the lazy V grid doing this? Why is it making them this size? Well, the HStack, it uses all the space it can. Whatever space it can get a hold of, it uses it, and it uses it in both directions, height and width. That's why we got tall cards that were as tall as they could be and as wide as they would fit. So that is the HStack's way that it distributes its space. A lazy V grid has a different strategy. It uses all the width horizontally for its columns, depending on the fixed and flexible in here. It's using all that space, but vertically it's going to make the cards as small as possible so we can fit as many as possible. So that, for example, if we go to emoji count 24 right here and resume, all 24 cards are going to fit in this lazy V grid, which is great for the lazy V grid. It's not exactly what we want in terms of the looks of our card, but you can see why lazy V grid is taking this strategy. And there's another thing to consider when it comes to these different strategies between lazy V grid and the HStack, which is this spacer right here. When we had an HStack here instead of a lazy V grid, the HStack was using all this space, so our spacer just ended up being this tiny little sliver of space between our buttons at the bottom. Here, I'll make it so we can select them. Our buttons at the bottom here, and the HStack that was at the top. But now that we've used the lazy V grid here, it doesn't use all its vertical space, and so the spacer has taken up all the space in between. And that's the way spacers work. They take any open space that's available that no one else wants. So these buttons didn't need any more space. The lazy V grid, this is all the space it needed, so there was extra space, and the spacer took it up. If I take the spacer out of here, I get a very different looking UI, because now these two things combine to make this V stack. This is the V stack on the outside here, and this V stack no longer needs the whole space, so it just centers what's in there. So that's why we see this V stack centered instead of using the whole space. When I put the spacer back, now there's somebody to absorb extra space, so the V stack will be as large as possible. So this is different kind of spacing here than using padding, which is fixed, and also using spacing as an argument to your V stack here. That's also fixed spacing. This is flexible spacing that absorbs any extra available space, and that causes other views like these and these to pin to the edges.
You change modify grid item, or maybe cards. I probably modify grid item.
Just want to make sure you understand the difference between using spacers here and just using padding or spacing. Okay, let's get back to making our cards look more like cards. What makes a card look good when it's like this? Well, it's kind of too wide for every 3 high. Its aspect ratio is kind of 2 to 3 approximately. And I want my cards to look like that, 2 wide, 3 high. If you look at most cards, playing cards, all these, they're generally about 2 to 3 in aspect ratio. Well, this shows a little bit of the power of SwiftUI, how easy it is to make these cards be 2 wide, 3 high. And that is with a view modifier called aspect ratio. I'm just going to 2/3. It has another little argument here called content mode. I'm going to do fit. Won't really talk too much about that. It's fit versus fill. That's just how it arranges the space that it's given. But you can see that this has immediately made all of these cards be 2 wide by 3 high in aspect ratio, still using all the width available to the number of columns that we have right here, but it's making the height match to be 2, 3. So if I made a lot more columns here, let's say we made 6 columns, I'm going to copy this and paste a whole bunch more, then again, they're still 2 wide to 3 high, but they're making fit 6 columns right there. The problem when we only had 3 columns, the cards were nice size actually, maybe a little too big, nice size, but they didn't fit on the screen. In fact, they pushed our plus minus buttons completely off the screen. If we go back into preview mode, you can see I can't even, I got too many here, but let's go back to 4, and that doesn't even fix the problem because watch. I have 4 cards, great. I'm gonna add some more cards, add another card. Oh, now my minus button is gone. So clearly this is not good. This view is expanding to fit, and now it's smashing into these other views. So what do we do when we have a really big view like this that can expand and smash into other things? Well, we can put it in a scroll view. And a scroll view is just another view, kind of like HStack or lazy V grid, that contains other views. So I just say scroll view, this in here, scroll view like that. Let's put this aspect ratio on another line so it's clearer. And now I have these 4 cards, and they're in a scroll view, you see? So now if I hit plus, 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 it actually added the card down there. You see? Plus another card. And now we can remove and add as many cards as we want. I'm going to take a second now to explain this word lazy in our lazy V grid. So a lazy V grid is lazy about accessing the body vars of all of its views. We only get the value of a body var in a lazy V grid for views that actually appear on screen, that scroll on screen. So this lazy V grid could scale to having thousands of cards, because in general, creating views is really lightweight. Usually a view is just a few vars, like is face up and content in our card view. But accessing a view's body is another story. That's going to create a whole bunch of other views and potentially cause some of their body vars to get accessed. So there's a lot of infrastructure in SwiftUI to only access a view's body var when absolutely necessary. This laziness we see in lazy V grid, that's only a minor example of that. We'll learn a lot more next week about how and when the system accesses a view's body var. This is looking really great. This is exactly what we want. Our cards are too big, so we can scroll around on them. But I actually notice a small problem here, which is that our card is actually getting slightly cut off. This scroll view cuts off anything that doesn't fit in the scrollable area, and it's cutting the edges of our card off. Now, with the resolution of the screen you're looking on, you probably can't see that, so let's go down and make our line width much larger, about 8. Now, hopefully you can see that it's cutting off. Here, make it even larger, say 12. And why is it cutting off this edge? Well, it has to do with how stroke works. Stroke draws a fat line, however fat you say there, 12 points in our case, draws this fat line around right on top of the border. So some of the line is spilling on the inside of the shape and some is spilling on the outside. And that's not actually what we want here. We want this entire border inside the boundaries of the shape. And there's a great function that does exactly that called stroke border. Okay, so this is a modifier that strokes, just like stroke does, but it strokes the border, so stroking on the inside. Exactly what we want. So now we can go back to our 3. Cards are looking good. They're not being cut off there. Let's go take a look and see what it looks like in light mode on our simulator. Make sure everything's working over there. And appears to be. Can add more cards. Scroll around. How about landscape mode? Yes, there it is. There's all of our cards. It's working here in landscape, but it doesn't look very good. These cards are way too big. And if you look at this simulator over here, when I go to landscape mode, it showed more cards. Right? It's showing 8 across right there, and only 4 in portrait. Whereas here we're showing 3, no matter what we're in, portrait or landscape. So how the heck did I get this version of the app to show more cards in landscape than in portrait? Well, there's a little trick we can do with lazy V grid that tells it to please plug as many things as you can fit across before you go to the next row. And here's how we do that. Instead of having 3 grid items where there's a fixed 3 columns right here, I'm actually going to have just 1 grid item. Now, this 1 grid item that I have is going to have a little special configuration so that instead of putting 1 card per row, so there's just 1 card, 1 column, 1 row, instead, we're going to ask the lazy V grid to take all these cards and pour them into this 1 column as much as will fit, then it can go to the next row. So it's kind of an odd way of describing what's going on, but we're really having 1 column, and that 1 column contains multiple items, and it just pours them in there. And it pours them in there sort of like text in a book, where the things that it's pouring are like words, and it just puts the words on, it gets to the end of the row, goes to the next one, puts more on, keeps going down to the next one. And it also justifies the text so that it picks the width that exactly fits like it was doing before. So how do we get our lazy B grid to do this? Well, we're going to take this 1 grid item right here, and instead of saying dot fixed or dot flexible, we're going to say dot adaptive. Now, when it pours these cards in there, lazy B grid is going to want to put as many of those cards in there as it can in each row. So we need to let it know the minimum width we're willing to accept for each of our card views. So we do that by just saying minimum. And let's pick something like 25, let's say. Oh, okay, so it took our 4 cards and poured them in there and made them as small as possible, but not smaller than 25. But 25 is clearly too small. Let's put more cards in there and see what happens. Go to 20 cards and resume. There we go, put 10 per row. Essentially wrapping again like text in a book, but that 25 is too small. Let's see what happens if we go to 100 as the minimum width. Well, at 100, we're back to 3 cards in each row, and obviously our cards aren't fitting. We're having to do the scroll view, so that's a little too big. Let's try something bigger, 65 maybe. 65 looks pretty good. That's 20 cards at least. Fits nicely. If we went to 24, we'd be back to scrolling, but that's certainly better. What about landscape mode? Let's go back to our simulator over here and rotate this thing into landscape. Ooh, look at that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it puts 9 across. So we get 9, 18, 20. Just got our scroll view here, luckily, because it's hard to pick a width that works well in both portrait and landscape. What we really want to do is pick our width based on how much screen real estate is being offered to us. Now, we'll learn how to do that later next week or the week after. But for now, we'll stick with 65, and we'll just rely on our scroll view here if we have to in landscape or if there's too many cards. Okay, that is it for this week. Next week, we will dive into the game logic for our memorized game. See you then.
For more, please visit us at stanford.edu.
Guess let's look at the reading assignments, the programming assignments. That's where the fun is. 10 pages. Okay. Before you start lecture 3, okay? It's the reading assignments. Damn, that girl's hot.
Looking for royalty-free music? Discover Epidemic Sound. Get the safest music
natural flow. Arrays and strings. Oh. Comes oh halfway over time. Yellow is weird, red is important. Well, I guess that's why they require SAT. Sounds weird.
Lucidchart makes intelligent diagramming easy and helps your best ideas become real.
Does it mean that all the music sounds distorted? Sounds kind of scary. This one today is also part of this week's readings. Swap. Sounds spooky. flow. Protocols options. This Unicode is the variable name. Turn on scale. Option notes. Chapter. Time. Inside the basics. Everything in C. C plus Python. You posted it, so plus Python. For value. Value at like value versus none in Python. Yep, but I need a type safe. I like explicitness. Okay, variables. This is constant, right? Variable. CC puts it here. That's so weird. Damn character. Python print is equal to use like those printf to cast the ones. C style commenting. The columns. That's very useful. It's got like an inf, negative inf, and positive. And data types. Warren Bradley. Do you all use double or single vision? Double, okay, double versus. This is a very important thing because the computation with integers is far much faster than computation with doubles. And when you run machine learning code, it has in numbers can cut the hours into probably cut your time by like 20% maybe. From experience actually. Oh, just like binary, octal, or hex, hexadecimal. Okay, pretty standard. It's kind of like, oh, otherwise it's pretty C stuff. Type conversions. Casting, very useful. Oh, it doesn't roll over, which is interesting. It was up there, what's that? Welcome back. Doing a reading assignment of the iOS class. 4 easy problems are too easy for us. I think I spent 10 minutes on it, but some people spend 10 minutes on 4 mediums. Some types I will saw in the lecture. Cuts it is not rounding. Oh. Pardon. Let's do that. Okay. Not very useful. Probably never. Yes. Actual booleans, or is it 1 or 2? Close. Access. almost like they're decomposing. We have more 5. It's the rest just score. Oh, if you third one scores. Sure. I probably use this most often. Return before returns. Optionals. Absence. Options can be used to cope with the absence of a value. But this may not exist because if it's ABC, it will not do anything. You do. Okay, does it? Is automatic set to no. Okay, if not none, this. Finding. Remembers if it's number do this, otherwise. Else. That's confusing. I'm gonna read it. I'm gonna bother. Cause I have no values. And wrap with it. List. Is the option you have to access wrap value. Forcibly unwrap it, but sometimes it's new. Am I trying for Fang? No, I came from Fang. And start my own business and side hustles. And use this knowledge for work. But this is not for Fang. Okay. Good. Yup. I turn my face cam. I'm actually wearing a shirt I bought when I was in Facebook. It's not really hard for someone to get into Fang, like, it's hard to get those good jobs. Fang hires a lot of people. Like, a lot. Yeah, trying to figure this out. Yeah, I mean, it's working on my trying to whip up my real camera, but doesn't. Actually, as a matter of fact, I think Almont actually stalked me on LinkedIn. So he knows where I work and where I have worked. You know, Fang doesn't make you special. I know a lot of places that are more selective and pays more and have better projects than Fang's in general. To give a few examples, like, for example, Stripe. For example, Roblox. For example, those. I think Lyft is pretty interesting too. A lot of places. You don't have to aim for the 5. Yeah, of course, there are thousands of companies, if not millions of them. Bang is just like a big corp. They don't even pay the most. Actually, they pay pretty subpar compared to some of these places. You never heard this combination of words before, have you? Bang, subpar. Sometimes. Like, going to this real day. But entry level, there are at least 7 companies that are paid more than any other things. At least 7. You are like L4 and 9 that pays more than Fang. Airbnb is most prestigious compared to Fang. Citadel, like those financial firms, pay much more than Fang. Some of these have very interesting work, right? Airbnb and Stripe, ByteDance. When ByteDance comes out like Snapchat, then Facebook gonna suffer. Like here, like the first thing show up. The rest are not things. And here, you still don't see Google, have you? L6, let alone most people don't make it past here. Even if you make it past here, it's still only like 2 fans out of here. Fang is not the jewels. They're good companies. They're not the best. Sounds arrogant, but just saw the data. They're very influential though. Very influential. Like if you look at Fang today, it's got like how you look at ExxonMobil and Oracle, maybe 20 years ago. 10, 20, 10. And that's how you look at Ford and General Motors, Toyota many years ago. They're good companies, very dominant, but they're not necessarily pay you the most or the most interesting to work at. A lot of them feel like they're like a screw in a factory in a huge machine. Even they hold the most prestigious degrees, but they end up just fixing a search bar on a page that not that many ever see. To me, that's really sad. Very sad. Well, now you know. What country are you from? Or what region are you from? Like, to be politically correct. Well, to be fair, most of those other companies are in the United States except ByteDance, so possible that Bang is the elite in some area. Sri Lanka. It's like South Asia. Yeah, they're not. They're probably very high up there. Probably very high up there. If you don't limit your scope, it would be the war is big. The war is big. And you saw those tech. The tech people think they are iPay and everything. Check the finance people. Like, this is like real stuff. The base salary, the developer base salary is like 1900K. like 190K. That's like higher than the absolute max of Amazon base. Like, I don't think any Amazon employees this much in base. And they have all those bonus comparable to stocks. Not even senior, it's developer. And this is like legit data because it's submitted to the government when they apply for visa and H1B and all that jazz. They didn't make it up. It will only be lower, it will not be higher. So, do you try catch? Standard stuff. Standard stuff. I should never use them. Assertions and preconditions. I gotta like check if nothing. I like an if check. Okay, cool. We did the reading assignment for the basics, the first portion. We got quite many portions to go through. Page 4, we have 10 pages. We'll see. We'll see. We're coding tomorrow though. Not tomorrow, but next time we stream. Next time is the binary search day, so anyway. Cool. Thanks for watching. Okay, see y'all later. Have a good weekend.